Okay, this is Algebra 2 with Trig, 1B.5. We're working with quadratic functions and models. We look down here at our first graph, and we notice that the point that they label here is down at the very bottom. It's the minimum value, h and k. The additional point that they gave us, it happens to be a y-intercept, but we're going to recognize it as just a random x and y along the graph. That's the only information we have. That's all we need when we're going to use vertex form. So y equals a, squaring the quantity x minus h plus k. What we're going to do is take our h and k values from our graph and substitute that into the equation. We have this x and y that we're going to plug values into. And that's going to leave us one final variable to solve for, and that's a. The a value is what we're looking for. You might be able to tell this one by looking at the graph and looking at the pattern of the points, but we're going to solve for it. When you write your final answer, one thing you need to remember is that your final answer has to have x's and y's in it. The x variable and the y variable have to be in your answer. There is a video available if you would like to click on that. You can get that at Canvas. Okay, so we're going to use vertex form to help solve this because they gave us the vertex and they gave us an additional point. We know that our x value is 0 and our y value is 5. Our h value is negative 2, and our k value is negative 3. Those are the values we know of. So 5 equals, we don't know about a yet, 0 minus, h is a negative 2. We're squaring that, and k is a negative 3. We don't have to write plus a negative 3, because that still means minus 3. So my minus a negative 2 is actually plus 2. Two negatives make a positive. So we're going to square the 2 to make 4. Now, a common mistake here is that people will take the 4 minus the 3. But remember, when you add and subtract, you have to have like terms. So this isn't just 4. This is actually a times 4. So other people would consider it 4a. So all we can do is bring our like terms together here, and that's where we get our 8. And we can divide by 4 to both sides to figure out that a was 2. You can kind of tell that a is 2 if you come over here and look at the original graph. Our parent function says we go over 1 and up 1. Our parent graph says we go over 2 and you square 2, and so you go up 4. Over 3 and up 9, and you would do that in the same directions on both sides of the line of symmetry. So you can see that this is more narrow than the parent function would be. So take a look at how far up you actually go. You actually go up twice as much. You go up 2. Here you go up 4 and then 4 more. So you're going up twice as much. So it does make sense that this is 2. You might have been able to look at this graph originally and seen that. Would like you to write out these steps in solving it. But you're definitely welcome to use your problem-solving skills to verify that your answers are making sense. So there's your equation that should represent this graph. Type this into your graphing calculator, and the table should show those points. Now we're going to come down to a different picture. So we're going to come down to our next example and look at what information is given to us. We look here and we notice right away this does not give us the vertex. And in fact, we have a hard time noticing how much 1 over is and how much up 1 is. So it's hard to tell if we're over 1 up 1. Hard to tell what that pattern's going to be. So we're looking here and we notice that this seems to be a random point. So this is going to be our x and the y. It's not a vertex. So it's not h and k. These points up here, if you notice, they're right on the x-axis. So this could be called your p, and this one could be called your q. So these are your x-intercepts. So we're going to try to solve this one using intercept mode, intercept form. So that's going to be y equals a, x minus p, x minus q. So we're going to substitute our p's and q's in for the equation. You're going to substitute your x and y of the other point into your equation. And that way we can solve for our a. And of course, when we write our answers, we need to be sure to write our equation with the variables x and y. There's a quick video here that can show you this process if you'd like to see that. So, because of the information they give us, we're going to use intercept form. We know what our P is, and our Q is, and our X and Y. We have all those values right from our graph. So we're going to substitute in the -4. We don't know A. That's what we're trying to calculate. So we got to leave that as the variable A. X is -2, and P is also a negative. So we have to use parentheses to say minus a negative. X is still -2, so we're going to plug in that -2 for the X. Minus Q. Q is just 2, so we don't necessarily need parentheses around that 2. So now we start cleaning this up. This is -2 plus 3. And -2 plus 3 is a value of 1. A value of -4. Some people get confused and think, well, you got 2 negatives, make a positive. That's only with multiplication. This here, we're adding together a -2 and a -2. That's a total of -4. So when we multiply -4 times 1, of course, we get -4. So A is 1. And when we look at our graph, we can start to believe that we come over 1, and it looks like we go up 1. We come over 2, and it looks like we come up 1, 2, 3, 4. So that seems reasonable. So I'll write our final equation as x plus 3 and x minus 2. The a value is 1. We don't need to necessarily write a 1 for the a value. Okay, your turn. Now take a look at what we have here. We'll set this one up. We may not take all the time to solve it right at this moment. I'll do it at the end. I want to be sure to give the other two the respect that we need. But notice what they're giving us here. What information is given to us? We see x-intercepts. We see a random point. So we know that we're going to use intercept form. So that's going to be y equals a, x minus p, x minus q. I know that my p is going to be negative 2 and my q is going to be 1. It's not 9, that's not g, that's q. And that my x is going to be negative 1 and my y is going to be negative 4. This is my x and my y. So go ahead and label your values. Then you're ready to plug them in and figure out what your a is. We would do the same thing over here on this side, where this is our h and our k. So our h is 2 and our k is 1. So we're going to use vertex form for this, which is y equals a, x minus h squared plus k. My random point is going to have an x of 0 and a y of 4. Any point that's actually on the graph is going to work. And we plug those in, find our a, be ready to write our equation. We'll come back and solve those out. What I want to spend some time at the moment is discussing what we have up here in the quadratic form in standard equation. Standard equation, remember, is y equals a, x squared plus bx plus c. So if we're given just 3 points, we're going to solve this in the same fashion as if we have a whole bunch of points. There are different ways that we can solve this one. This one does not require that you use a calculator, but that's the method that we're going to use here. I'm going to show you something new. I'm going to clear out my calculator. All right. So I'm going to go to Stat. And in Stat, we go to Edit. Stat's above the 8, a few rows up. And then we go right to Edit. We're going to put our x's in the first line. Those are all our x's. We're going to put our y's in the second column. So our points are negative 2, negative 6, 0, 6, 2, 2. We put our points into the calculator. We're going to go back to Stat. We'll go over to Calc. Now there's a whole bunch of different calculations that happen in here. This is called Quadratic Regression. If you have points, you can calculate an equation, or at least like a best fit line. So we want to do this in a quadratic form. So we're going to hit enter. Your calculator might show you multiple lines and say calculate at the bottom and tell you stuff about L1 and L2 and so forth. If you go down to calculate, or if you're on this type of calculator, you'll just hit enter and you should see that your A value is going to be negative 2, your B value is going to be positive 2, and your C value is going to be 6. So we plug those values into our list, and we can write our equation as negative 2x squared plus 2x plus 6. This gave it to us in standard form, not vertex form, not intercept form, but right to standard form. The only thing that's different with the last question down here, besides the different type of questions that they ask, the only thing that's different is in stat and edit, you're going to type in all of these as x values. Often in this situation, I'm just typing right over the ones that I had. You can clear your stat by hitting clear, just don't hit delete. Just got to reset your calculator if you hit delete. So I typed in all my x's and all my y's into the list. Just like we did before with the 3 points, I did it with all of these points. And we're going to do the same exact thing again. We're going to go to Stat and over to Calc and down to Quadratic, because that's what we're making, Quadratic Regression. Down here it asks for what's a quadratic model. Your screen might be a little bit different. It might show different lines in here with information in there. But if you go down to calculate, you'll find out that your A value is negative 0.177 x squared plus 14.656 x, and your constant value is negative 20.272. There is your quadratic model. From this point, we can talk about a scatter plot. We can talk about the A value. Okay, if you notice here in the middle, your A value starts to drop, or your values of Y start to drop, get smaller. So what sign will A have to be? It will be negative. The Y values drop as X approaches infinity. As X gets bigger, the Y values are getting smaller. So that's how I knew that. And then we can come down here and we can talk about what's going to be our approximation at 270 feet. So to figure out, the fence is 270 feet from home plate. What angle, or multiple angles, to the nearest tenth of a degree will the ball be hit past this left field fence? So what we need to do is, it looks like 270 is going to happen at right near 34, but we can calculate a little bit better than that. So what we're going to do is get this equation on our calculator. So we're going to look at table. Oh, I haven't put it in. Let's put that into our y equals negative 0.177 x squared plus 14.656 minus 20.272 272. There are other ways to get it plugged in there, but this is a pretty good approximation. We didn't round the numbers too much. It'll be great work. So now we can look at table, and we can see that we start to reach a maximum height. It's going up forever here. So we're supposed to be checking that 270 spot. But what I wanted to do is to see what's happening to my values. I'm not finding a pattern here. So if we start looking that as x starts to get bigger, our y value is getting bigger. And here we're at 270, and then we're at 280, and we keep 270. Oh, it's coming back down now. So it started to come back down right around where x was 40, 42. Looks like this one here was the highest one at 44. It's not the vertex because it's not balanced on either side, but that's a good starting point. So I'm assuming, you gotta always watch assuming stuff, but that is definitely our height. No assumption about it. So that tells us we have a height of 280 when our x is 41. So if we take our x, let's go out even further than that. Let's go out twice that amount. So we'll say 100. And we know our height has to be that 280, so let's say 300. So now when we graph this, we can get a good representation of what our graph's going to be. And if we want to look at 270, we can look at where that would cross. There's two different angle values that are going to get us to 270 feet. So if we do our intersect, second calc, different calc than we used in stat, but second calc, intersect, we have our first curve, and our second equation is right there. That's our second curve, and our cursor has to be closest. So we have an x value at 32.7, they say to the nearest tenth. So 32.8 degrees. And then we're going to say second calc. We'll go to intersect again. And it asks us for our first curve. Is that our first equation? Yes. Is that our second equation that we're working with, the 270? Yes. I need to come over to the other intersection, anywhere near it, and hit enter. And it's going to tell me at an angle of 50.0 degrees. So that's what it's going to take to get up to 270. Create a scatter plot of the values in the calculator. Well, I have those values. If we've got our window, okay? If we go to scatter plot, this is new. If we go to scatter plot, so second y equals, and we're going to go in here and turn it on. We're going to ask it to do a scatter plot, so that's that symbol. We're taking our x values from what we put into list 1 and list 2, and we're going to use this symbol. And when we graph it, you will now see that that path is the scatter plot of the data. So we created our path. We see that that was actually a parabola type shape. So we created our scatter plot. Okay. The data has a maximum value. And we have a maximum value there, and then it starts to decrease again. We knew our A value was negative because it opens downwards. We found our equation, and we answered a question. We'll come back up now and pick up a few of these additional ones. I'm going to clear my calculator, second memory 712. And that clears the RAM. I don't have to worry about stuff being in it. So I'm going to go to Stat, to Edit, and I can type in my points. First I do my X's. Then I can scroll over and do my Y's. So those are your 3 points by going to Stat, Calc over to Quadratic Regression. You might have a calculator that shows multiple lines, talks about L1 and L2, has the word calculate. You got to scroll down to calculate. And it's going to give you these 3 A, B, and C values. So y equals negative 2x squared plus 0x plus c. So really all you need to write is a negative 2x squared plus 6. I can slide here, finish this up. We know that our y equals, we're looking for a. Let's see, our y value is actually negative 4. Our x value is negative 1 minus a negative 2. Our x value is negative 1 minus a 1. So negative 1 plus 2, because you're minusing a negative. So that gives us value of 1 times negative 2. When you multiply those two values together, you get negative 2, and by dividing across, a equals 2. So y equals 2, x plus 2, x minus 1. And then this one's in vertex form. We know our y value is 4, our x value is 0, our h value, this would have to be this guy, h was 2, and our k value is 1. So 4, subtract the 1 across, square your negative 2, and divide. So a is going to be a little crazy looking one at 3/4. So our equation is y equals 3/4 x minus 2 squared plus 1. So we knew what our h and k was from the given information. We knew what our x and y was from the given information. And we plugged our values in as we had previously, and we came up with our equation. A little crazy, but we did it.